welcome back to the deep dive. We've had some really cool deep dives lately, but this one I think you're really going to like. We're tackling chaos theory today, and let me tell you, this one's going to change how you see things, how you see the world.
It really is a fascinating topic, full of surprises.
Yeah, and it's not about randomness. I think that's the first thing, right? It's not random.
Right.
It's about systems, systems that are so sensitive, like to their initial conditions, that it's impossible to predict what will happen long term, even though there are rules. You know what I mean?
Exactly. Yeah.
So think weather patterns or the stock market or even your own heartbeat.
Yeah, it's all connected in a way, and yet those connections often lead to outcomes that are really hard to predict.
Absolutely. And we've got, some really cool sources here that we're gonna dive into, and we're gonna uncover the mysteries of the butterfly effect and why something that seems small can have huge consequences.
I think that's the thing that people find so intriguing about chaos theory.
It is intriguing.
This idea that something so tiny can ultimately lead to something massive and unpredictable.
Yeah, it's almost a paradox, right? Because on one hand, you've got, you were saying these chaotic systems are still governed by laws.
Right. They are deterministic, meaning they follow rules.
Okay.
But on the other hand, those tiny variations at the start can send the whole system off on a completely different course.
Okay, so it's deterministic, meaning it follows rules, but also unpredictable.
Precisely.
That's kind of hard. Like, how do I wrap my head around that?
Well, I think about it like a game of billiards.
Okay.
If you hit that cue ball with even a microscopic, difference in angle or force, the final position of all the balls on the table is going to be totally different.
Oh, okay.
Yeah.
Okay, so that's a good analogy. So like a tiny change at the beginning leads to a big difference, a huge difference at the end.
Exactly. And that's really the essence of chaos theory, that sensitivity to initial conditions.
Okay. I see that. But how does that then play out in something like weather forecasting?
Well, that's where the famous butterfly effect comes into play.
Okay.
Back in the 1960s, there was this meteorologist named Edward Lorenz.
Okay.
And he was, running weather simulations on his computer, and he decided to rerun one of the simulations. But, instead of entering the full data set, he rounded off a few decimal places, thinking it wouldn't make a big difference.
Wait, so just a rounding error, like a tiny little rounding error, did that really mess things up?
It did, actually. That tiny change in the initial conditions led to a completely different weather prediction. And that's how he stumbled upon this concept of the butterfly effect. The idea that something as small as a butterfly flapping its wings in Brazil could theoretically set off a chain of events that leads to a hurricane in Florida weeks later.
Wow, that's crazy. That's wild.
It is. It's this interconnectedness that we often don't see or appreciate.
Okay, so even if we have all the equations and data, these tiny little events, seemingly insignificant, can completely change the outcome.
Right, and it makes long-term predictions incredibly challenging, if not impossible.
So does that mean long-term planning is just futile? Like, why even bother?
Well, that's a great question, and it's one that people, grapple with all the time, especially when you're dealing with really complex systems.
Right.
But I think before we jump into that, we should, maybe talk a bit about another key concept in chaos theory, and that's nonlinearity.
Nonlinearity. Okay, yeah.
Yeah.
That sounds a little intimidating. I don't know, but okay, yeah. Break it down for me.
Well, think about it this way. Nonlinearity just means that, the relationship between cause and effect, it's not a straight line. You know what I mean?
Okay.
It's not one-to-one. Small changes can snowball into much larger effects. And as you can imagine, that makes long-term predictions really tough.
So it's not just like if this then that.
Right.
It's more like a ripple effect.
Exactly. It's like a viral tweet. Think about that.
Okay.
One person posts something, and depending on how it resonates with other people, it can just explode and have a huge impact.
That's true. Right.
So the initial action, the tweet, is small, but the outcome can be massive and unpredictable.
I see what you mean, yeah.
Yeah.
That makes a lot of sense. I remember in the source material we were looking at, there was something about predator-prey relationships and how that's a good example of this.
Absolutely. Let's say, for example, there's a slight increase in the rabbit population in a certain area.
Okay.
Now, you might think, more rabbits, that's a good thing for the foxes, right? Right, yeah.
They have more food. And yeah, at first you might see an increase in the fox population.
Okay.
But then as the fox population keeps growing, they might overhunt the rabbits,
Right. Right.
causing the rabbit population to crash, which then impacts the foxes, and so on and so on.
Oh, so it's not just more rabbits, more foxes. It's like there's this more complex kind of dance between cause and effect.
Exactly.
And the outcome isn't always what you expect.
Right. It's not always intuitive. It's not always a simple one-to-one relationship.
And it's not just more rabbits, more foxes. Yeah. It's like this complex dance between cause and effect, and the outcome isn't always what you'd expect. It's kind of wild to think about, how connected everything is, even in ways that we don't always see. Have you ever experienced something like that, where a small action had like a surprisingly big effect, good or bad?
It's like a domino effect sometimes.
Yeah.
One thing leads to another, and before you know it, the whole landscape has shifted. Totally, totally. And it's in all that chaos right there. There are these patterns that emerge. It's like there's a method to the madness. It's kind of cool when you think about it. And that, I think, brings us to another really fascinating concept in chaos theory. Strange attractors. Have you heard about these?
Oh, strange attractors. Yeah, they're like hidden magnets within the chaos, pulling the system toward certain patterns.
Okay. Now you got my attention. What are those?
Okay, so imagine a chaotic system, right? Like a point moving through space.
Okay.
Now, over time, it might seem like this point is just, jumping around randomly. But a strange attractor, what it does is it reveals that there's actually some kind of underlying structure guiding its movement.
Oh, okay.
It's not completely random. It's confined to a certain region, and it traces out a specific pattern, almost like a hidden choreography.
Okay, so there's a kind of order within the chaos. That's a mind-bending concept.
It is. It's this idea that even within these seemingly unpredictable systems, there are still these attractors that are shaping the overall behavior.
That's so cool. So do you have like a good example of this, of a strange attractor, something I could picture in my head?
Sure. One of the most famous examples is the Lorentz attractor.
Okay.
Named after the same Edward Lorenz who discovered the butterfly effect.
Right.
And the Lorentz attractor, what it does is it creates this visual pattern that looks kind of like a butterfly.
Okay.
And that shape, it really shows how chaotic systems are often bounded, right? They're not just flying off in random directions.
Okay, I can picture that. It's like there are these invisible walls guiding the chaos.
Yeah. A good analogy might be like a pachinko machine.
Okay.
You know how the ball bounces around, seemingly at random, right?
Yep.
But it's still confined within the structure of that machine.
Right.
There's a kind of order within that randomness.
Absolutely. Now, our source material also talks about fractals.
Yeah.
Fractals and self-similarity. How do those fit into all of this?
Oh, fractals. They're fascinating structures, aren't they?
They are. And I have to admit, I don't fully understand them. So break it down for me. Like, where do we see them in the real world?
Well, they're everywhere once you start looking for them.
Really?
Coastlines, for instance. Have you ever noticed how coastlines have that jagged, irregular shape?
Sure, yeah.
Now, if you zoom in on a map, look at the smaller inlets and bays, they often have a similar shape to the larger coastline.
Right, okay.
It's that self-similarity across different scales.
Oh, wow. I never thought of it that way. Okay. What other examples are there?
Trees.
Yeah.
The way branches grow and split into smaller branches.
Okay.
They resemble that larger structure of the whole tree. It's that same kind of pattern repeating itself.
I'm starting to see fractals everywhere now.
And don't forget our own bodies, our network of blood vessels.
Oh, wow.
From the largest arteries down to the tiniest capillaries, they all exhibit these fractal patterns. It's amazing.
That is amazing. So simple rules repeated over and over again lead to this like incredible complexity.
Exactly.
And how does this relate to chaos theory specifically?
Well, fractals really illustrate how complexity can arise from these simple origins, right? It's kind of like how those tiny changes in initial conditions can lead to these massive complex outcomes in chaotic systems.
Oh, okay. I see that connection.
And speaking of those outcomes, maybe we should shift gears a bit and talk about how chaos theory is actually applied in different fields.
Yes. Let's get practical. I'm really curious to hear how this all plays out in the real world.
Right. Well, remember how we talked about the butterfly effect earlier and the challenges of weather prediction?
Mm-hmm.
Well, that's a perfect example of chaos theory in action.
Okay, yeah.
The atmosphere, it's a chaotic system. Tiny changes in temperature, pressure, wind speed, they can all lead to these wildly different weather patterns.
So like those 7-day forecasts we see on the news, you're saying they're not always reliable.
Well, they can give you a general idea, but the further out you go, the less accurate they become.
Okay.
It's like trying to predict where that pachinko ball is going to land
Yeah.
after 100 bounces.
Right, right. That makes sense.
Meteorologists use this technique called ensemble forecasting, and that's actually rooted in chaos theory.
Okay.
So what they do is, instead of relying on a single prediction, they run multiple simulations with slightly different initial conditions,
Okay.
and that creates a range of possible outcomes.
So they're acknowledging the inherent uncertainty.
Exactly. They're embracing it. They're saying, look, we can't predict the future with absolute certainty, but we can understand the range of possibilities and the probabilities of those possibilities.
That's interesting. So what about other applications? Like where else do we see chaos theory being used?
Let's move on to ecology. Remember those predator-prey relationships we talked about?
Mm-hmm.
Well, they're just one example of how chaos theory plays out in these ecosystems.
Right.
Tiny changes in species populations, whether it's due to disease or environmental changes or even human intervention,
Yeah.
it can have these cascading effects throughout the whole food web.
Yeah, it's like a delicate balancing act, right?
Exactly.
Where even a small nudge can throw the whole system off.
Precisely. And chaos theory helps ecologists to really understand, like, the complexity of those interactions and why preserving biodiversity is so crucial.
Okay, that makes sense.
Yeah.
So it's not just about protecting individual species, it's about understanding the whole web of life and how it all fits together.
Right. It's about seeing the interconnectedness of everything. But chaos theory doesn't stop at the ecosystem level, It also applies to our own bodies.
Wait, so you're saying my own body operates on principles of chaos?
To some extent, yes. Think about it, Our heartbeats, our brain activity, the way our cells communicate, they all exhibit this chaotic behavior. It's this intricate interplay of feedback loops and these nonlinear dynamics that really allow our bodies to adapt and function in this constantly changing environment.
So chaos is like literally keeping us alive.
In a way, yes. It's this inherent unpredictability that allows for flexibility and adaptation.
Mhm.
It's what allows us to respond to new challenges and maintain this kind of dynamic equilibrium.
That's incredible. Who would have thought? I never would have thought of chaos in that way. What about something like the stock market? Like I've always wondered why it just seems so unpredictable.
Well, chaos theory offers some really interesting insights into that as well. Stock markets are complex systems. They're influenced by a dizzying number of factors, from individual investor behavior to global economic trends. It's everything.
So it's not just about picking the right stocks at the right time.
No, it's much more than that.
All right.
Chaos theory suggests that predicting those stock market fluctuations with any kind of certainty it's almost impossible, because even these small events can trigger large-scale changes.
That explains why even financial experts often get things wrong,
Right.
Yeah.
No one has a crystal ball.
Right. No crystal ball.
And chaos theory really encourages us to approach financial predictions with caution and always remember the inherent uncertainties of the market. It's all about embracing the unexpected. And speaking of unexpected applications, chaos theory is even being used to design better airplanes.
Wait, what? Chaos theory in airplanes. How is that even possible?
It might seem strange at first, but it actually makes a lot of sense when you think about it.
Okay.
Engineers have to deal with all sorts of complex systems, like airflow over wings or the combustion process in an engine. And these systems, they often exhibit chaotic behavior, especially turbulence.
Turbulence. That's what makes flights bumpy.
Right. Exactly. And understanding how that turbulence works is absolutely crucial for designing, more efficient and safer aircraft. By applying chaos theory, engineers can model and predict those turbulent flows, and that can lead to improvements in aerodynamic design and even fuel efficiency.
So chaos theory is helping us fly better and more sustainably.
It is, and the applications don't stop there, Chaos theory is being used to design quieter cars, building more stable bridges, even developing more effective medical treatments. It's about recognizing that complexity and using it to our advantage.
This is incredible. We've seen how chaos theory is used in such diverse fields, from predicting the weather to understanding the human body, to navigating the stock market, to designing cutting-edge technology. It's mind-blowing to see how this one theory can connect so many seemingly different areas.
It's really quite remarkable, isn't it? How this one concept, this idea of chaos, can provide insights into so many different aspects of our world. And we've really only just scratched the surface. There's still so much more to explore and discover.
Welcome back to the deep dive. We've covered a lot of ground so far, haven't we? I mean, chaos theory, who knew? Who knew it was so everywhere. Weather patterns, the stock market, even our bodies. It's really remarkable.
It really is. It shows you just how interconnected everything is and how even the smallest changes can have these huge ripple effects.
Absolutely.
Mm.
And in this final part, we're gonna venture into a whole new area. We're gonna see how chaos theory helps us understand, you know, human behavior and societal dynamics. Like, how does chaos theory apply to people and societies?
It's a fascinating area of study, because human behavior, it can definitely feel chaotic at times. But there are patterns there, just like in those other systems we talked about.
Okay, so is there really a pattern to all that seeming randomness? Like, how does that work?
Well, think about it. Our decisions, the way we interact with each other, the way societies evolve, it's all influenced by so many factors, countless factors, really. And a lot of those factors, they're unpredictable, right?
Right, right.
So chaos theory gives us this framework for understanding these complex systems, these human systems, and it shows us how small changes can lead to these large-scale shifts, these societal shifts.
So it's not just about individual choices, right? It's about how those choices interact and create this ripple effect throughout society.
Exactly. Exactly. Think about how ideas spread or how trends catch on or even social movements. It might start with a single tweet or a blog post or a protest.
Okay.
But that can spark a chain reaction that spreads rapidly in ways that you can't always predict. And that can lead to some really significant changes, cultural changes, political changes.
It's like the butterfly effect, but on a societal scale.
Exactly. It's that sensitivity to initial conditions, but now it's playing out in the realm of human interaction and social dynamics.
So it really highlights how interconnected we all are, right?
Yeah.
I mean, something small, something seemingly insignificant can just snowball into something huge.
It can. And it reminds us that we're all part of these complex systems, these human systems, and that our actions have consequences, both intended and unintended.
Okay, so if we can't predict the future of society, with any kind of certainty, does that mean we're just along for the ride? Like, is there anything we can do with this knowledge?
That's a great question, and it's one that a lot of people ask when they first encounter chaos theory. But while chaos theory does emphasize the limits of prediction, it also gives us some really valuable insights into, how to navigate this complexity.
Yeah.
By understanding those principles of feedback loops, nonlinearity, the sensitivity to those initial conditions, we can become more aware of the potential consequences of our actions.
Okay, so it's about recognizing those patterns, understanding how interconnected things are, and just being prepared for the unexpected.
Exactly. It's about embracing uncertainty and adapting to those changing circumstances, and even, seeing the beauty in those emergent patterns that arise from these complex systems.
That's a good point. I mean, it's easy to get overwhelmed by the chaos, but there's also something kind of beautiful about it, the way things unfold.
Absolutely. There's a certain elegance to it, a kind of organized chaos.
This has been an incredible deep dive. Really, really incredible. We've learned how chaos theory applies to, I mean, everything from weather patterns to the stock market to human behavior. It's just amazing to see how this one theory, this one idea can connect so many seemingly different fields. So as we wrap things up, I want to leave you with a thought. Where do you see chaos at play in your own life? Maybe it's in your daily routine or your relationships or even your career path. How can this newfound understanding of chaos theory change your perspective, embrace the uncertainty, stay curious, and see what amazing patterns you might discover? Thanks for joining us on the deep dive.